Hello students, in this video today I will discuss about reactivity series and different types of oxides. So first see reactivity series. Figure 6.6, this is the reactivity series of different metals. So what is the reactivity series? This is the arrangement of metals in a series in decreasing order of their reactivity is known as reactivity series of metal. The arrangement of metals in a series in decreasing order of their reactivity is known as the metal reactivity series. In this reactivity series of metal, you can see some metals like sodium, potassium, calcium, sodium. These metals are highly reactive metals, and these metals that reacts with water. Some metals like magnesium, aluminium, zinc, Fe, that is iron, nickel, tin, lead. These metals are moderately reactive metals, and these metals react with acids. Here it is given, and some metals below hydrogen in the reactivity series of metal, hydrogen is given although it is not metal. Okay, the metals below hydrogen in the reactivity series are least reactive. They are highly unreactive metals. These are also called noble metal. Metals like copper, mercury, silver and gold, these metals are least reactive metal. Okay, so from this reactivity series it is cleared from top to bottom. Top to bottom, reactivity of metals decreases. Reactivity of the metals decreases. In this reactivity series, you can see most reactive metals are placed at the top of the reactivity series. Most reactive metal is potassium, and least reactive metal is gold. From this reactivity series you can tell which metal is most reactive and which metal is least reactive. Okay, now see the special feature of the metal reactivity series. As we move down potassium to gold, the reactivity of metal decreases. This indicates potassium is the most reactive and gold is the least reactive metal. Remember that. Second, the metals present at the top of the metals are the metals present at the top of the metal reactivity series can displace metal present lower down in the metal reactivity series. That is, a more reactive metal can displace a less reactive metal. Okay, a metal that present at the top of the metal reactivity series can displace metals present lower down in the metal reactivity series. And hydrogen is not a metal, but it is listed in this reactivity series for comparison. Generally, metals that are above hydrogen in this reactivity series, the metals that are above hydrogen in the series can displace hydrogen ion from water, acid and alkali. Okay, and the metals below hydrogen cannot do so. Now see, next topic is oxide and their classification. Oxide and their classification. Here one small portion is given, predicting the reactivity of metals. Predicting reactivity of metals. We know that more reactive metals such as zinc, iron, magnesium, aluminium can displace metals below them in the reactivity series from their salt solution. For example, when zinc rod is dipped in copper sulfate solution, as zinc is more reactive than copper, zinc displaces copper from copper sulfate solution. Okay, similarly Fe can displace copper from copper sulfate because Fe is more reactive than copper. Okay, zinc can displace hydrogen from H2SO4 because zinc is more reactive than hydrogen according to the reactivity series. Okay, now say oxide and their classification. Oxides. What are oxide? Oxides is a binary compound in which oxygen is present as anion. In which oxygen is present as anion. Oxide is a binary compound in which oxygen is present as an anion. For example, CO2, carbon dioxide, is an oxide. MgO, magnesium oxide, these are oxide. So types of oxide, 4 types of oxide: acidic oxide, basic oxide, amphoteric oxide and neutral oxide. So first type of oxide is acidic oxide. Generally non-metallic oxide are acidic oxide. Non-metallic oxide, when nonmetals react with oxygen they form acidic oxide, and the bonding present in acidic oxide is covalent bond. Okay, so acidic oxide form oxide through covalent bond. So acidic oxide is formed by non-metals. When non-metals combine with oxygen through covalent bond, you will get acidic oxide. Example of acidic oxide: carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide. All these non-metallic oxide are acidic oxide, and these acidic oxides are covalent compound and have low boiling and melting point. Second type of oxide, one more thing I want to mention, that acidic oxides can produce acid when it is treated with water. For example, when sulfur dioxide is dissolved in water, you will get sulfuric acid, H2SO4. As acidic oxide can produce acid when treated with water, these oxides are called acidic oxide. Okay. Second type of oxide is basic oxide. That is metallic oxide. Oxide of most metal are basic, and these oxides are formed through ionic bond or electrovalent bond, and hence they have high melting point and boiling point. Okay, so generally metallic oxide like calcium oxide, magnesium oxide, CaO, MgO, FeO, Na2O, all these metallic oxides are basic oxides. And basic oxide when treated with water can form base. For example, when sodium oxide Na2O, sodium oxide Na2O is treated with water, sodium hydroxide, which is a base, sodium hydroxide is formed. Okay, so basic oxide combines with water to form base. Third type of oxide is amphoteric oxide. Amphoteric, they can act both as acidic oxide and basic oxide. Okay, so these are oxide of some metals. These are also metallic oxide. These are the oxides of some metals which show properties of both acid as well as base. Example of amphoteric oxides are aluminum oxide, zinc oxide and lead oxide, Al2O3, ZnO and PbO. These are example of amphoteric oxide. This amphoteric oxide can react with both acid and with base also. Okay. For example, when aluminum oxide reacts with sodium hydroxide, sodium hydroxide is a base. So in this case, aluminum oxide Al2O3 act as acid because it reacts with base to form sodium aluminate NaAlO2 and water, salt and water. Okay, so in this case, aluminum oxide act as acid. Similarly, when aluminum oxide reacts with H2SO4, H2SO4 is an acid. So when Al2O3 act as when Al2O3 aluminum oxide reacts with sulfuric acid, in this case Al2O3 aluminum oxide act as a base. Okay, so Al2O3 that is base and H2SO4 that is acid. salt and water, aluminum sulfate salt and water H2O. Okay, these are actually neutralization reaction. So Al2O3 can react with base and with acid also. Okay, that is why Al2O3 is an amphoteric oxide. And last type of oxide is neutral oxide. Neutral oxides are generally non-metallic oxide. Okay, so these are oxide which do not show either acidic or basic properties. For example, carbon monoxide, nitric oxide, nitrous oxide, all these are some examples of neutral oxide. Okay, so you have to remember the definition of different type of oxide with example. There are 4 type of oxides. Thank you students, and this chapter is completed.